Here's a cool idea you can add to your horror games. Having a monster move only when the player looks away. There are two lines of code that make up the core of this feature. We start by creating some values to keep track of. The first being player location, by storing the object's transform value along with the orientation, which will help us tell where the player is looking. The next value we need is a float, which will be the end result of our operation. In update, we will start by creating a vector 3, which will be the result of taking the player's position and the other object's position. I will call this the observed object. We subtract the player position vector from the observed object position, then normalize this value to leave us with the angle between the two objects. So our next line is the dot product calculation. We will start with our new vector 3 and give it the player's forward orientation. This dot product function will do all the work we need to get the float value that we can use to tell if the player is looking at the observed object. So before we run any code, let's make sure to attach the script to the observed object and give it access to our player's orientation. Just click, drag, and drop. Your script should look a little different, as I made some modifications off camera to try and explain how this feature works in the code. There's a number value for the float scalar we calculated with our dot product formula. In our scene, you can see the number value on the right, which represents the result of our dot product formula. Our number value is almost at 1, because we were looking very directly at the observed object. Moving 90 degrees to our left or right makes the number value go close to 0. Lastly, if we look directly backwards from the observed object, it goes to -1. From our top cam, we can see how valuable this number is for determining if we are looking at the observed object. Notice as I move the player position, because we make the vector 3 of the difference between our player and the observed object, we can move freely and still get accurate numbers of if we are looking or not, regardless of changing positions and angles. We need to create a float, which I will call the threshold. This float that we will set will determine what the value of the dot product can be before something happens, basically letting us control our action based on where we are looking. So, if our dot product is less than or equal to our threshold, then it will do something. For example, I'm adding a particle to turn on when looking away. Now for this example, if we code it right, we'll see that nothing happens. And as you can see, nothing happens. But if we look from our top cam view, once the player turns just far enough, then the red particles activate, just out of our first-person view. Our threshold is set to 0.5, so keep in mind of your player's camera field of view when creating this feature. This piece of code is very flexible to your needs. You can change it so things only move in the corner of your eye, or make the threshold really narrow to guarantee that the player never sees it. In this example, we flipped the sign to our threshold to make things happen when we are looking at the object. We see this figure hide behind the gravestones only when we look at it. Another idea can be to make something move when you look away. These cameras update their look position the second the player looks away. And here's the classic example of statues that move towards you when you look away, and they slowly surround you until you're trapped.